Oh man, that Neuromusc quiz was pretty tough, huh?
Sarcomeres.
What? Yeah, I really gotta unwind. I think this cocaine will do the trick.
Hell yeah.
Yeah, let's hit it.
What is going on here? What's up? Hey! Did you guys juice cocaine?
Yeah!
You know, I really wonder what's going on in their synapses right now. Okay. Wouldn't it just be wild to know? It would be wild. You want to figure it out? Let's figure it out. Let's do it. Let's do it.
Here we have a normal synapse with a presynaptic membrane and a postsynaptic membrane. The first step of neurotransmitter release is an action potential that travels down the axon from the axon hillock to the axon terminal. This action potential opens voltage-gated ion channels containing, letting calcium into the presynaptic cell. This calcium triggers the fusion of vesicles that contain neurotransmitter with the neural membrane. These vesicles fuse and spill their contents, which are neurotransmitters, into the cleft. The neurotransmitters released into the synapse and will bind to the postsynaptic receptors. These neurotransmitters either excite or inhibit the postsynaptic cell. The neurotransmitters can be deactivated one of three ways. Either enzymatic degradation, an enzyme will come into the synaptic cleft and degrade the neurotransmitter. The neurotransmitter could be reuptook by the presynaptic membrane through the reuptake pumps, or the neurotransmitter can diffuse out of the synaptic cleft and out of the synapse.
In regards to our whacked out monkey friends we saw in the previous scene and the hairy tobacco farmer, who are both high as a kite on cocaine, the same is true in their brains and in their synapse, except until the point of where the neurotransmitters are released. Now, when these neurotransmitters are released, just like before, they are released into the synaptic cleft. And there's actually three different types, specific types of neurotransmitters.
First off, we have dopamine, which is responsible for the dependency feeling on the cocaine. Second is norepinephrine, providing energy for the individual. And lastly, serotonin, providing confidence for that individual.
Now, when these neurotransmitters go and bind to the postsynaptic membrane, they create a graded EPSP potential and causing the effect. And now normally, the neurotransmitters would come back into the cleft and would actually be reuptaked by certain receptors or transporters. However, cocaine blocks these transporters so that the neurotransmitters cannot be reuptake. So therefore, the neurotransmitters are stuck in the synaptic cleft, prolonging the effects of dependency, energy, and confidence in the individual.
In typical synaptic neurotransmission, we have one presynaptic neuron that sends a neurotransmitter across the synaptic cleft and it binds to a ligand-gated channel in the postsynaptic membrane. However, in the case of cocaine use, we are now working with neuromodulatory neurotransmitters, and so we have a presynaptic neuron that is sending different neuromodulatory systems out into the synaptic cleft, and they are binding to metabotropic G protein receptors on a wide range or many different postsynaptic membranes. These different neuromodulatory systems are dopamine, norepinephrine, and serotonin.
As Chris alluded to, neuromodulatory systems play a significant role in cocaine use. The dopamine, serotonin, and norepinephrine systems are concentrated in the deep cerebellar nuclei, the tectum, the basal ganglia, and the basal forebrain. These parts of the brain are responsible for the dependency, the excessive confidence, and high energy levels of people when they are high on cocaine. Well, that just about wraps it up for neuromodulation. Let's go check on our whacked out monkey friend to see how she's feeling.
I'm out of energy and I don't feel confident. But I am still dependent.